I'm Bhavidhir V. Bharadwaj. Welcome to episode 24 of Genesis of Tomorrow. The following is a conversation about generative AI, computer vision, medical imaging, augmented reality, entrepreneurship, and more with Dr. Debanga Raj Neog, Assistant Professor in Artificial Intelligence at IIT Guwahati and co-founder of Nytilus, a computational imaging startup with his PhD in computer science from the University of British Columbia. Also, 86.1% of you watching this have not subscribed yet. So if you get even the slightest bit of value from our show, please support us by clicking that subscribe button so that we can keep improving the quality of the episodes and keep on bringing such wonderful guests over for you. And now, without any further ado, let's get right into it. Enjoy and thank you. And we are rolling now. First of all, welcome, Dr. Neog. It's delightful to have you here. And there are a few different aspects that I think we should be talking about, ranging from generative AI to computer vision and their applications and all these things. But let's, I think a good place to start this entire conversation would be what is your particular area of expertise and interest more so?
Right. First of all, thank you. It's great to be here today talking to you. And if I talk about myself and my research work, so I'm very much interested in working in the domain of computer vision. And as you know, these days, computer vision is all about applying, AI technologies to solve computer vision problems where we have cameras that is capturing an image or a video and then figuring out intelligently using some AI technology what kind of insights you can get out of it, right? So that has been the area I've been working on since I was in my bachelor's, and I'm still pursuing it.
Computer vision has got these different, like it's of the primary three domains that AI can be segregated into: data science, computer vision, and NLP. And rightly so, then computer vision has got these different use case types. What are some of the most prominent implications of computer vision that it is being utilized in right now, and what are some of these areas that you think it will affect to a very large degree in the upcoming years?
Right. So it's a very good question. So as I see personally, what computer vision is, I see this is a an kind of area that has been applied to different sectors. So how I see it, as we all know that if I talk about AI, AI is a kind of umbrella term that covers your traditional logic based AI technologies and also machine learning, where we are driven by data. And now, when you talk about machine learning, and even inside that, we talk about artificial neural network or deep neural networks, they have been applied to computer vision uh, uh, for many years. We can talk about last 2-3 decades, but it all stems, I think, from image processing in some way, because when we talk about video, that is predominantly the source, the signal that we use in computer vision. It's a collection of frames, right? There's images, and as we know that 30 frames, one standard rate through which we see it through our eyes. We see it as a video. We cannot tell the differentiate between the frames. Now, when it comes to videos, we can think of anything that can be captured using a camera or some device. Again, when I say camera, it's not necessarily color images, color videos. It can be your infrared, or any kind of even laser. You can or some radar. So those are also kind of signals that can be captured by sensor, which is a temporal signal. Now, if you can capture any kind of phenomena that's happening in the world using this kind of devices or sensors, which is, for example, temporal, then basically that data you can analyze using computer vision, right? And many times what happens, if it's a video, then definitely you can apply our traditional computer vision techniques. And many times you'll see that even the signal is not in the format of a vision, still you can convert it to some kind of signal that is 2D and temporal, and that can also be analyzed using computer vision techniques. So if you talk about applications, uh, any sector, for example, whether it's a healthcare, it's an education, it's it's about transportation, there are so many areas that people are increasingly now using, relying on devices. For example, safe driving car, if you talk about, it's a bunch of sensors that's helping the car to figure out how to move, right, effectively in a very complicated environment. And in that case, computer vision is being used so that you can detect pedestrians, or detect an object that's in front of it, detect the traffic lights. So that is one application. If you talk about healthcare, we have different biomedical images, for example, x-rays, CT scans. So from there, how can we figure out that there's some disease or there's some tumor, the presence of a tumor? So that can also be solved, although x-ray is not a temporal signal, but still it's an image processing technique. And these days, actually, image processing and computer vision are kind of merging together in a way. We are calling all as computer vision. So this is an application of healthcare. Then one more application I can give is, for example, agriculture. Let's say you're using some drones, right? Drones to apply fertilizers or some kind of chemicals, so that you can get rid of some pests. So in that case, you may use drone that is flying, hovering on the field. So in that case also, it can be steered in a proper way over the field using, for example, cameras or other kind of sensors. So that also, the data can be collected through the camera, for example, and then computer vision can tell that this direction you have to go, or this is the area you have to apply for where you didn't apply before those chemicals. This is one example, right? So these are different ways you can utilize computer vision. So it's not just that for example, only on surveillance, or only on very obvious areas where like video camera is used, you can only apply, right? And that is the first thing. So the summary is that there are anything under the sun that utilizes this kind of devices with a sensor that capturing information, that can be computer vision can be applied prominently in the uh, video signals, but any other temporal signals can be converted to in a format that can be utilized for vision. Second thing I want to say that uh, the computer vision has a lot of kind of future. I'm very optimistic about it. The reason is that when I talk about vision, um, vision is one of the modalities of different kind of signals. We talk about speech, we talk about text, we talk about videos, images on, right? So there's a new kind of technologies coming in, which is multimodal AI, right? So where this model is not just, you can say that it is a computer vision model, it's a multimodal AI that can include, that can capture the vision data, text data, speech data, and together it collects all the information and take a decision. So one example I can give is that, for example, in healthcare, right? In healthcare, let's say you have an X-ray for a particular patient. At the same time, you have some prescription given by doctors, or some kind of comments already given by some radiologist, for example, and you have that person's clinical history, right? So now, just only relying on the X-ray or some kind of biomedical record, can we utilize all these modalities, like his history, medical history, that person's his or hers um, other information that can be collected, and for example, EEG signals or something like that, right? And how can an AI capture everything and then apply an algorithm? So this way, computer vision will be, anyway, is very important part of a lot of modalities. So that's why it is a lot of future. And now, how is going to change? This is, I think, one of the questions that you asked. I think by kind of answering the first questions, I kind of given you hint that it's going to be there, right? And one interesting thing is that uh, if you look back like 30, 40 years ago, people didn't have smartphones like the way that we have, right? So now whenever we go, we click a picture, record a video. So the visual data has been increasing, right? The data is growing a lot. So uh, when we have data these days, it's an era of AI. Whenever we see data, we're very happy, because now we can feed it to an AI, and then AI will be taking decisions, right? So as long as we have videos, images we've been capturing every day, I think computer vision will be there. And along with our most of the prominent applications that we see are, in particular, like we use it in Instagram, or the reels that we make, right? A lot of features that we use that utilizes, for example, capturing your face and putting some on top of it, like some filters. These are again driven by computer vision. But personally, I want computer vision to go not only to the entertainment side, but in more AI for good, where the areas which are very important for a country like India to grow, like healthcare, agriculture, education. There, I think these kind of tools have to be used as much as possible. Yeah.
I'll I'd love to come back and to touch upon singular aspects of this entire broad description that you gave. But before that, let's go back a little to something more specific to your particular journey.
Right.
You did your bachelor's and then you decided to pursue master's and then subsequently a PhD in computer science.
Right.
What do you think was your frame of mind or motivation back then to take the path or go down the route of academia? And then subsequently, the second, this is the first part of the question. Second part is you also have been very closely uh, related with the side of industry and entrepreneurship. How
Right.
did that transition came to? And yes, this balance between industry and academia, how were you able to maintain it, and what motivates you to keep on maintaining it?
Yes. So to be honest, I personally I'm a very flexible person in the sense that I always try to experiment new things. And although always had some kind of goal, but I'm pretty adaptive to the situation. So I always I'm not very rigid to my goals. And of course, behind the scene, the driving force that I have is I'm very competitive in whatever I do. I want to excel in it. At the same time, I am also always yearning to learn new things. So I think when I joined IIT Guwahati, I was in ECE department back in 2007. I joined. During that time, I just wanted to go to an IIT and to see how can I get in. That's of course I prepared a lot for my JE advanced mains, and but finally what I got in, I wanted to do some research, but I didn't have any clear idea like what has to be done and something. I didn't do a lot of research on how to do research. Okay, everything lot of things has become accidental in a way. I'll tell you how. um, I when I was in my high school, I wanted to become an IS officer, right? So one day my mom told that these days a lot of students who are IIT graduates, they are getting into IS. So I said, great, I can do that as well. So of course I was good at maths and science, so I felt like this is a great way to go. Uh, but when I entered IIT, then I met a lot of faculties and doing a lot of research. I was very fascinated by that. And in particular, I recall in the second year, I was in second year in the winter. I was looking for some projects to do, and I thought that I'm just in the second year, so I just will do some projects with some of the faculties here at IIT Guwahati. So I think I recall I went to three faculties, one from computer science and two from triple E departments. And I met the faculties and I said I'm interested in do some projects. I think the CSE faculty gave me some topic on networking, and one of the triple E faculties gave me on some how to related some hardware project, and which is basically architecture of the computers and how to how it works and things. So you have to simulate on in software. And the third project I did was in image processing. In fact, you can say computer vision. Okay, it was on how to recognize gestures from by using a camera. Like if I show one or two or three, how can this software tell you that I'm showing one or two? So I did all of the three, and then finally I somehow found I found myself more interested in the computer vision project. The reason is that I'm also personally a very visual person. So when at the time I was using MATLAB, so when I run something and I actually see it in a picture format or video format, I really liked it. So I decided this is something that I'll not get bored by doing, even I do it for years or years. So I think that is very important to figure out that you don't want to do something just because other people are doing. It has to genuinely come from your inside that you can sustain in the long run, right? So that's how everything started. And I recall that one of the projects I did in the third year was hand gesture control a robot moving around on a surface. Like if I show one, it goes to right, two to left, and so on. So all these things I did. I recall I wrote the software part as well, and in hardware part I partnered with one of my friend during the time, and we completed the project. So that gave me a lot of confidence that actually I can also build something which is, tangible. It's just not like few lines of code, but actually I build a kind of a device that is moving, that is controlled by vision, computer vision. So that was a very fun experience. And at the same time, during the third year I also applied for some projects outside our country, if I can join in the summer as a co-op. And internship case, I think in the third year summer I went to two universities, one in Japan and one in Korea. And I think because I had a background, because from the second year onwards I was actually getting preparing myself uh, with a lot of basic knowledge about computer vision image processing. And that also first of all helped me to get to those internships in the summer. At the same time, I didn't have to really, go through the basics during the internship time. So I was able to almost 100% utilize the time, because I just went there and directly started the projects. So I think because of that, from these two internships that I did in that summer, I got two conference papers from these two internships. So that really helped me in future also when I applied for my PhD, having papers. And also the projects that I did, as I told you, in the second year I started, that also ended up becoming my BTP project, BTech project in the fourth year. And also I think we got like one or two more conferences or two or three journals from there. So as you can see from the beginning, just because I was very passionate about it, I was interested, it ended up things went well. And I think so. I applied for many universities when I was in my fourth year. And I recall, you also have a lot of peer pressure, right? When you're in the fourth year for placements, uh, your friends are getting, planning for some high paid jobs and this and that. So I was a little bit, perturbed by that as well, because all my friends are, going for those interviews. What should I do? I almost 98% clear that I want to go for research and for high studies, but that 2%, are very challenging. So I recall I went to one of those placement interviews one day, and there was a group discussion. So I just didn't feel good. I didn't think that this is what I want to do. And after that, I didn't sit for placement, because I was said, okay, that actually helped me to make it clear that this is not what I want to do. I want to go for research, right? So things went well. And then I got into this University of British Columbia in Vancouver, Canada. This was actually known as PhD track program, so master's leading to PhD. So if you feel like after entering the program that you don't want to go for a PhD, you can leave with a master's, and if not, then you can continue as a PhD. So I took some time, 6 months, and then I again felt like I want to do a PhD, so I continued. And one thing that I think I didn't tell, that during my J preparation, one subject that I hated was chemistry. Somehow it is the most scoring, but I don't know why. Uh, I, I just didn't like that much, right? And but when you get to a IIT, like through JE rank, typically you don't have control over it, right? Unless you have very good rank, you can say I will get into IIT B CSE. But if you are in somewhere in 1,000 to 2,000, you cannot guarantee, right? You just fill up the form and then you just pray God that I get it right. So I got to the chemical department. So right. So but then I figured out that there's an option called branch change. So but I was a topper in that chemical branch that year, so I changed my department to ECE. I also tried CSE actually, but my by one position, because there's a very limited number of seats you can change the branches. So I didn't get CSE, but I get ECE. But my luck was good that a lot of computer vision, which is considered as a part of CSE in many of the universities outside, a lot of faculties are doing here in EC. So but I picked a project that finally led to me applying for computer science in when I'm for my PhD, right? So ultimately I end up in CSE in university, right? And for my PhD. And but the project, the group that I went to, It was in computer graphics, not actually computer vision. But my supervisor, Professor Dinesh Pai, he actually looked into my profile, and he said that we can do one thing, that since you are from computer vision, we can do this. That anyway, he was working on creating realistic human motions, rendering of human faces for things like movies, games, and so on. So he said, why not we do this? We took a data driven approach where we'll be capturing human faces with a very high quality in a camera, high quality capture, and then we look at the deformation of the human face, and then take it as a data, and then train a ML model that will be able to generate those realistic motions. Right? So that's how we are trying to connect computer vision with computer graphics, because the capturing part where you're tracking the details of the human face is very difficult, because the texture is not very obvious, and tracking a deformable object is very difficult than tracking a rigid object. And then connecting to animation, right? So that becomes computer graphics. So that also helped me to learn a lot about, starting from how computer vision and computer graphics connected. I kind of learned from the both of the sides. That also helped me a lot. On top of that, I was working on human face motion. So that means you have to understand how human musculature works, what kind of muscles are there that when they are activated, they creates, raising of the brows or eye movements. So I also worked on eye tracking and face tracking. And at the same time, I also learned a lot of things about neuroscience. So the whole work that I did during my PhD is, you can think of like a connection. It's a triangle of neuroscience, computer vision, and computer graphics. So all the things that I kind of got into picture. Now comes this turning point, like when I decided to start a company, startup. That I would say I was not a very extrovert person, introvert person. Mostly, I consider myself. I was not very confident going out and talking to people. I used to just like to study, stay in home, and code mostly. That's what I was person is. Regarding the code, I can code for 8, 9 hours, 10 hours continuously. It doesn't matter to me. This is something that I'm very passionate about. So even I don't eat, I don't care. So I feel like it's a very comfort zone for me, just with the computers creating something, right? So one of my friend, he was doing MBA. He was planning to do, and then he was a little bit more, I mean, he was not like me, he was extrovert a little bit than me. So what we decided, okay, we have to change ourselves, because in this world communication is also very important. So what we used to do is that we used to go out to different meetups, just to push ourselves to and a group of people and start talking. So we did a lot. And in one day, me and my friend was talking about can we do some startup, where people go to the meetups, and then they can share cars, for example, carpooling. In particular, in Vancouver, at least, we can try, when if we figure out some events, and we can talk to the organizer and then say that, give me the list of the people coming in, and somehow we create a web app or app that people can talk to each other, somehow connect, and then share the car. So this is one of the things that we thought of. We did some work as well. It didn't work out that much, but this was a very nice experience for us to learn about things. So this is I was doing when I was in the third year of my PhD, right? So then he also had some commitments, so he kind of left for his own personal reasons. So it didn't work out that way. But during, I think, the final year, when I almost completed all my experiments regarding to my thesis, uh, I got an opportunity to go to Montreal from Vancouver, and there was an incubator that actually gives some funding to start your own startup. In particular, they were onto deep tech, so they were funding some technology-based startups. So I went there, and then I met my co-founder, that actually I set up this company in Nytilus. That I met him, and ultimately we didn't continue in that place, incubator, but we separately, with my business partner, we started a company. And that company was mostly working on utilizing a VR headset for welding, where our idea was that my business partner, he actually used to make a lot of robotic equipments. So he know how difficult it is to do weld. In particular, it's a very dirty and dangerous environment, because this UV lights is coming out of this welding. If it enters your eyes, he has actually has suffered when he was in bachelor's. He was taken to hospital, for example, and he couldn't sleep for many days. So he knew the pain. So with that pain with him, and then me being in computer vision, and I also worked in some AR and VR. So we thought that why not we could actually make a headset like that, where people can see through, not directly through the welding spot, but through a display that is in the VR headset. And on top of that, we can put some information like how fast you are doing the welding, what is the angle you're holding, because those are the metrics that kind of determines what is the quality of your welding, right? So this is what our idea was. And I'll not go to the details of the company, how it worked, and this. I will come back to that a little bit. But I'll just trying to try light on how my life has been, like, revolving around a lot of different things. And I never consider anything as a failure, but I have learned so much during the whole process, right? So it was a very courageous decision, I will say myself now when I look back, that when you are in the final year of PhD, before even doing your synopsis kind of thing, and you decided to go to a different city and start something, and telling your supervisor that I'll write my thesis slowly, or I'll take my time, my own sweet time. So that also, of course, delayed my thesis a little bit, but in the meantime I was learning a lot of new things in my startup. So we got some fundings from some accelerator programs also. So as a part of it, I was in Dubai for 6 months, pitching to a lot of VCs in Dubai, and they're developing our product and so on. In the meantime, I was also in for 3 to 4 months. I was in Belgium, again for a different accelerator program, where I spent a lot of time talking to different VCs there, and talking to a lot of potential clients, demonstrating some of the demos that we have prepared. So that was a very different world, being in academia, being a PhD, sitting in the lab working, and suddenly you're going outside the world, meeting people who are doing businesses, pitching. So that really changed my life. I know, going from that guy who was sitting inside the dorm coding, to someone who is pitching to some of the big names, going to some very luxurious places, sitting with VCs talking about businesses. So in Dubai, I recall there are some hotels that we went. It was totally golden. I went to some 20th floor and met with some VC. It's a very amazing experience. And so this continued. And actually, as I have already told, that this product is has a hardware component, right? So we found a lot of challenges during COVID time, because a lot of the devices, like the displays, cameras, they come from China. So COVID-19 was a very hard time for us, because we will not be able to procure a lot of stuff because of that. Everything was delayed. But anyway, long story short, during 2021, so during, as we know, that during COVID time, the flight to Canada was banned for a long time. I was not able to return to my home. And the COVID-19 was a very serious situation. Lockdowns were there. So at some point of time during 2021, early 2021, there was a window that opened of the flights, and then I decided to visit India for 2 months or 3 months. And then I kind of made up the decision that, okay, now I'm feeling like I want to return home, because it was very difficult for me time in Canada during that time. And one day we had this kind of serious discussion with my co-founder that uh, I may want to change the course a little bit now, because he may take over the business side, and now I may want to go to India. But it was not sure. But I have given him some hints. And during that time, once I returned, then again, the because of COVID, something happened again. Flight got banned, right? So I was stuck here. And I applied for my PR, but somehow, because of COVID, which was supposed to be in 6 months, it took more than 2 years. It's not happening. So during that time, I one day my dad told me that there's an opening in IIT Guwahati. Why don't you apply for a faculty position? So I applied, and I got it. So it was almost by September I got the letter that I got accepted in the faculty position. And then I had to take a decision, right? Should I take this offer or not? Like, it was a tough decision, because one place I was waiting for my PR in Canada, and here I'm getting a job here. uh, but one very strong kind of point that helped me in taking decision is that I got into a job in IIT Guwahati, and my hometown is in Guwahati. My family is in here. Everyone is here. So I felt like this is a time maybe I have to sacrifice something and take a bold decision. So I decided to stay. And after joining IIT Guwahati, after 1 week, I got a PR acceptance also with me and my wife both. But anyway, I had taken the decision. So, and I'm pretty happy with my decision so far, because IIT Guwahati is somewhere that I got my bachelor's, and the faculties who taught me now, they are actually my colleagues, and they're helping me a lot. So this is a journey that I had, and now uh, we have ours. I have joined this Meta Family School of Data Science and AI. This also gives an opportunity to you know uh, be in touch with so many students and people, and you see that everyone is looking to you, in a way that, as a teacher, uh, it feels really good when you deliver something and then it impacts and helps people at that large scale, and that's rewarding, very rewarding, and that I feel like I'm very happy about it. And plus, of course, everything starts from there, right? When I did my computer vision project of my hand gesture recognition, and now I'm here doing research on this kind of same area. So it's very nice. It feels very nice. Yeah.
Okay, two different aspects, but your choice, whichever you want to take first.
Yes.
Firstly, uh, how do these algorithms, machine learning algorithms in particular, they are able to mm, they are able to derive meaning out of real time data processing, right? Because you did say initially that irregular figures and motions, they are relatively harder to
Mm.
detect and apply algorithms onto.
Right.
How do these current machine learning algorithms are able to mathematically dissect and geometrically analyze real
Right.
time motions, and a theoretical explanation in that
Mm.
regard? And
Right.
secondly, you again mentioned that you had to research on how to research during your
Yes.
early
Yes.
bachelor's time. So, touch upon that a bit. As somebody who is maybe with no research experience, prior research experience, how do they start or begin their journey into research and, in general, being able to publish their own papers and
Right.
all of that?
Right. Right. So first, I'll try to answer the first question. Um, so if we look at the history, like from the classical machine learning to our current, very advanced deep learning techniques that we're using, which are, for example, transformer based models that is driving those large language models now. So what have changed? That's what we have to look at. First of all, the classical models were very limited because, as many of us know, that the feature extractions were very manual, right? So, for example, if I want to find a dog in an image, I have to manually design some features like how ear looks like, how eye looks like. And then you'll search for those features, and then figure out, okay, there are some eyes. Then it could be a dog or a cat. Then basically you have to figure out all those features, right? And on top of that, definitely we have some basic paradigms like supervised and unsupervised, and all those algorithms, all the paradigms are there of machine learning. So if I, for example, look at supervised, we have this classification. Let's take one example, right? So you classify whether particular object is a house or a car. Now, what are the why we have to go towards deep learning, not our classical methods, right? That's what we have to look at. So many of the classical methods, the basis is some linear model, mostly. Of course, there are some non-linears also, like random forest is not necessarily a linear model. But many of the popular models, if you look at, they are, you can think of like a function, right? You give some input, it gives predicts some output, right? And the capacity and the quality of the predictions, whether it's a regression or classification, it depends on how good your model is, right? That you can think of also like a function or a black box, let's say, for now, right? So when you're, if that particular model is good, it will be able to perform some the classification or regression well. It's like a human brain, right? If someone instructs a person that do this, and how efficiently that person does it, it depends on his experience, his or her experience, exposure to this kind of activities in the past, right? If someone is very smart, you'll do it very well. If it's not very smart, he might haphazardly do it, Now, what actually difference between these two persons, right? Who is very smart and is haphazard? Most probably, the smart person has put some lot of work, or maybe a little bit of genetic. I don't know, right? Don't want to comment on that. But somehow the brain is being trained, or these features of the brain, that the filters you can do in the convolution filters we talk about. This is very good, right? It is able to extract the meaningful things, meaningful context, and take a decision. Now, when you talk about, let's say, an example, now we go for deep learning techniques. So how they're different from the classical methods? First of all, this manual feature extraction is gone, right? Because from the data, it can automatically figure out what kind of things to learn. So now you might ask, how is it possible? How is it possible is, I was saying that in the past, people were extracting the features manually by some experts. Experts tell you, okay, look for ears, look for eyes, then you'll be able to decide whether what kind of animal this is, let's say. Now, that what expert was saying, you have to do this way, that way, that expert is also being learned from the data. That is how it is different. Now that expert sits inside the model, and that also is saying that expert is also not known, let's learn it from the data. So that's why there is one big benefit that we get when you go for this the ANN that we get these days, right? And the second thing is that these models are very complex compared to your standard linear regression or some polynomial regression or even SVM. This model are very complex and is coming from all these tons of layers that we are having, or the newer architectures that we are having, like transformers and so on. So the complexity of model has increased, and if we have a very complex model, we are able to model a lot of complex phenomenon, whether it's tracking of deformable objects or any kind of complex phenomenon that's happening. The challenge comes, if a very very complex model, to train the model, you require a lot of data, right? To train the model, you require a very high compute, right? And you need a very good algorithm that is able to optimize this model. Now, good thing is that now we have a lot of data coming in slowly. Of course, in some areas it's still challenging. For example, healthcare, some rare occurrences of diseases is not there, but people are working on generating synthetic data using generative AI, like GANs and all those kind of models. Second thing is, it's about the compute. We have GPUs now. Hardware is also becoming accessible. Now people can run GPUs in Google Colab. They can pay a minimal monthly fee, and then they can get access to very high-end GPUs to some extent. And of course, look at the amount of research going on. Every month, thousands and thousands of papers coming out. That means a lot of people now are focused on developing algorithms which can train AI algorithms properly, more efficiently. Then you also talked about real-time data, right? Now, where the real-time data is more important? Of course, face tracking and eye tracking is one of the examples I said. When I'm talking, you have to in real time track my lips or my eyes, right, to understand something. But look at some practical use cases also, like in the field, for example, agriculture, right? In agriculture, you have a lot of sensors lying there, and you have to, in real time, maybe you have to collect the data and take a decision, right? Or vehicles, for example, self-driving vehicles. The cameras cannot wait for 30 seconds to take the next decision. It has to continuously being fed by a lot of, bombarded by a lot of information. And how we can efficiently do it in real time? Real time means it has to be taken decision in in milliseconds, right? You cannot wait for 3 seconds or 4 seconds. By the time you'll maybe hit someone, right? So for that, another area is coming in, which is like how you can do efficient inferencing in a low compute device, maybe in a chip or in a small compute board, right? So efficient inferencing is also one topic where people are doing different techniques, like pruning. They are doing quantization. Those are techniques where, given a model, you can optimize it by changing the precision from floating to int, right, by reducing the size and compute. At the same time, sometimes you figure out that there are some connections in the network which are not relevant for me. They are always multiplied by 0, so let's not do that. So some pruning can also be done. So these are the techniques that's helping us to optimize the algorithm, the models, in a way that the accuracy is not being affected that much. Maybe you have reduced the size of the model by half, and your accuracy is dropped by 0.01%. That's okay, right, in many cases. But that is allowing us to do real-time computation, right? So those kind of things are also done. And in particular, it's very challenging whenever you are using video. There's a lot of data actually, right? It's not a 1D signal, it's a 2D signal, it's a 3D signal, in fact, if you consider time also as a third dimension. So it's a lot of data, and how efficiently do it, that the researchers are constantly working on it. So this is kind of a very brief answer to the first question. And going to the second question
Before
about
before before you go into the second question,
yes, yes,
probably digging this aspect a little more.
sure,
When
sure,
you
right.
talk about deep learning models and neural networks,
Yes.
we are basically trying to mimic the functioning of the human brain with them, how
Hmm.
neurons work and fire. If you are a neural network, you are
Hmm.
a robot which has been calibrated with neural network and deep learning
Right.
models, how would your perception of this visual data differ from what a normal human comprehends and sees just naturally?
See, I would not say that the deep neural network is an exact replica of human brain. So what I would say is that it's inspired by how human brains work, right? So in fact, I can also say that the way that the neural networks are working, it may not be exactly, may not at all be similar to how a human brain, processes some visual data, right? So when the visual signal comes to our eyes, it falls on the sensor retina, and then it's through the nerve signal, it goes to our human brain processes it, and then you kind of take a decision, right? Or maybe some way in human brain, it's not necessary that it's the same. The only thing that is same is that there's a concept called, neuron, which is almost they're trying to mimic how actually neurons human in a brain the neurons work, where you have multiple signals coming in, and then one for example, dendrites and axons are going out of the new neurons, and how there is as an activation signal that actually activates the neuron or deactivates it. So these are kind of similar how our neurons real human brain work. But a network that we're building, for example, when you talk about CNN, how we are using convolution and all, they're not necessarily exactly that's happening there. Some kind of similarity may be there. Yeah. So yeah. So if we look at the newer algorithms that we see, whether it's a transformer or CNN, there are a lot of variations, and our human brain cannot vary like that, right? Human brain is a fixed brain. It doesn't say that, now I select transformer, now I select CNN. So we are trying to use that concept of neuron in the networks, right? But the architecture itself is not necessarily same as how human brain works. But you always see that there are some clever uh, techniques that people use. For example, if you look at the newer transformer models, there's a concept called attention, right? So that's a very interesting concept, because when you look at the data, you're just not focusing on one part and taking a decision, then again go to the next part, taking a decision. You may look at the whole data and figure out there's some relevance connection between one part of the data to the other part of the data. So if I talk about an image, for example, when I'm taking a decision that whether it's a dog or a cat, I'm not just relying on whether a dog is there. I'm also looking at some surrounding, and if there are some objects these are very common to be nearby a dog, that can also help me in taking a decision, right? Now again, human brain people, scientists have been doing a lot of research, but they are also not exactly 100% can tell that this is the system, that's it, and you just do it in this way, right? What we know is that what is the input and what is the output. That is the data most probably we have in a supervised fashion, right? So we know that if we see some information coming to us through our five senses, you know and then something human brain does and output is this. But we cannot probe into your brain and see how you're doing it, right? Most probably yes, people are trying to put some shapes and all, but it's a very rudimentary still, right? But what AI is telling us that, fine, I know what is going in your brain. Let's say let's some n number of tasks is given to me, right? Like 10 tasks given me, and I performed in a particular way, 10 different to each of the tasks. Now for a third person or someone, let's say you are looking at me and you said, okay, if this kind of input comes, Devanga does this particular way, right? Now if there's an exhaustive list of tasks, let's say, right, why would I care how the system is working? If I have an AI that does exactly the same thing as I did, for me maybe it is sufficient. Now that may be doing in some other connections through other way, not exactly how human brains doing. But for me, both are equivalent. Like Turing test, right? It's not necessarily human, but some AI is doing something, right? Maybe that may be sufficient for them. So that's what happening in these days. Also, these AIs are coming out, right? Large language models. They are doing so well in most of the tasks, right? Like these days, what are the benchmarks and all? But to me, I really don't care whether it's like human brain or not, as long as they're behaving like how a smart agent will do. I'm fine with that, right? So that's what happening. So I will not say they're exactly similar, but ultimately we are more focusing more on input and output, how they're behaving. Yeah.
I think I get it. I agree with even the people who are studying the human brain specifically towards the
Right.
biological and neuroscientific side of
Right.
things. They are also most of the tangible research and outcomes that they've derived are generally related towards causation, causality, and
Right.
correlation
Right.
between the input data and the output data, as you
Right.
said.
Right. Right. Right.
And I think it's absolutely correct that when we are building an AI model, the objective is to be able to derive a sensible data
Yes.
output
Yes.
from a set of
Right.
input
Right.
data.
Right.
But okay, again, coming back to the prior aspect, research.
Yes.
For somebody with no prior background of research and knowledge, how do they develop that?
So if I think about during my time in the second year, for example, where mostly I decided that this is something that I really like and maybe want to pursue for a long term, I think that time is very sensitive. The reason is that during that time we are also so kind of naive in a way that we don't have the experience part, right? We are learning things, but we don't have the experience. Like now, it's easy for me to tell do this or do that because I have been through this. I have failed many times. I have figured out how to solve the problem, and then again coming back. So first of all, you have to surround yourself by the right persons. Like now if you think when I think myself when I was in a bachelor's and BTech while doing BTech, so whom I was talking to, I was talking to my seniors, my peers. If I know someone who has been in job or research, right, my professors and my parents. uh, Now you think about going research, although it sounds great, someone should do, right? It's very nice, you're actually coming up some novel ideas that can help the community. This is a great motivation, no doubt. But it depends on a lot of other factors. For example, what is your family economic condition, right? Maybe job is very important for your family. So in that case, I will not say that you go for research right away, right? I mean, it depends on the situation. So in that case, how can someone think of both jobs and research? It's very difficult, right? So that is one of the factors. Sometimes even that is not a factor, but somehow you getting a lot of family pressure, that they have this rough idea that IIT means someone goes in and comes out with a very high package. With that mindset, when you how some students are not ready, not mentally ready to confront that the parents and tell that I want to go for research, not job. For them it's a like, what are you going to do? Like, this is a big mistake. Those kind of things, once the parents or someone say it, you cannot proceed with it, right? So I'm very lucky to have a kind of a family that supported me when I say that I want to do a research. They said okay, fine, right? So that is the first thing, has to come from home. Your family is very important, right? So they have to agree with you, uh, to some extent. Sometimes even they don't agree, then you really feel strong motivation that you have to convince them in some way. You have to tell them, not by fighting. You tell with evidence that this is the thing, these people have done this way, my seniors have done the way, they might have done for research, but they have come back to industry after that, they're earning money. It's fine, but just they have to just bear for a few more years, that's all. So you cannot fight with your home, right? So that's not a great way. So you have to figure out how to convince them. So that is the first barrier you have, one of the barriers many I have seen, right? The second thing is that you will also have peer pressure, right? A lot of your seniors, even though you know that you want to do it, but if most of the people you're surrounded by telling that no, job is the way to go, and you're relying on seniors who's in the third year, let's say, or fourth year, they also haven't have much experience to this, right? So they might also feel like, again, from a different system, they are feeling that job is the only way. is the only thing should be done, and then you are taking an advice from them, that also causes problem. Now you are lucky when you meet some seniors who have selected this path. So I was also lucky to have some seniors who are actually going for research, planning to go for research. So that motivated me a lot. So that is a second kind of barrier that you have sometimes. How can break out of this peer pressure and do what others are doing, right? Then third thing is that you have to find some good mentors in terms of faculties, whether it's in your institute or outside institute, right? So that is very important. And I was also lucky to have my supervisor who was very supportive, and he provided a lot of guidance in this. So then, as I said, the mentor is also very important. So I was lucky to have my BTech supervisor. He had constantly helped me in guiding, what are the universities out there, how to apply for it. And this information, by the way, I also got from many other sources as well. As I said, my some senior colleagues who were preparing for research and PhDs, masters and PhDs. Then I also got information from when I went to my internship. I That was a very great experience, because I first time I went outside our country doing, and I came to know about a lot of research culture in other universities outside India, in Japan and South Korea. So there also I met a lot of met, of course, my mentors there. And at the same time I met with a lot of other students. They were also preparing for higher studies, so I also got to know a lot from them. So I was constantly trying to get as much as information possible, in terms of what is the ranking of the universities, what are the research labs. And I also got to know that it's very important uh, to look at also the lab on along with university. Of course, the high ranked university is always good, because that's just like how, when you say you're from IIT, there's a lot of brand value. Similarly, if you go to top 100 universities in the world, definitely some branding effect is always there. It always helps you. Even I can see that effect when I was starting up, when we went to VCs to talk. When I say I'm from IIT graduate, then they know it. So it was such a powerful brand. At the same time, when I say I'm from UVC, and then they also get a brand value. So that adds a lot of things. So I learned that whenever you try to push yourself, so that even not now, later on, also somewhere, if you get a brand name, because even you are not from IITs, even if you do a PhD from some very good university, that ultimately becomes a brand, right? Even you do a postdoc, that also becomes a brand. So even not now, I think that everyone should try at some point of time to get a brand that will help throughout the whole life, right? So that is very important. So always it's good to try high. And also learned this thing that, based on all my information that I gathered, that when you apply for higher studies, you should always have a list where you should not put all high ranked universities. There should be some very high ranked, some mid range, and some bit lower range. Low means I don't saying that go too low, but maybe you can go up to 150, 200 ranks is okay. The reason is that in case you don't get into the high one, you have a backup option. And it's up to you whether you want to go there or not. But that comfort that you have, that kind of confidence you have, that I was getting there. I mean, it's not that I was totally. Sometimes, when nothing goes your own way, you feel like you are useless. That kind of feeling comes many times in a life. It's just a mental thing, but but that way, that if you have a choice, right? So that also, when someone comes to me and say, where should I apply, I said, you have to diversify your application portfolio, right? It always helps, right? And that is one very important thing. And of course, you have to be everything should be very planned. So I was clear that if I don't get publication, it becomes very difficult to get straight away to a good university. So I was focusing on publishing as much as I can. That means you going beyond the normal your coursework and all, putting some extra effort, learn how to write, learn how to write a paper. Those are very, very useful experiences later on, because even when you go for PhDs or masters, your supervisor also sees you that how well trained you are. They don't have to tell you all the basics. They see that right away you are starting to write papers or doing a project. So that is a very good thing. um, One more thing I learned is that building connections, right? So some of the connections I got from Japan and Korea when I was visiting there, some of the mentors that I have, they were also visiting a lot of universities in US and Canada. So through them, I also got a lot of connections from them. Apply. So it's always easier when you know someone from the university, some faculties prior, and then you apply to his or her lab. Life becomes a little bit easier for you because they know you, right? It's kind of referral they got from other faculty who is also well known. That also helps a lot. So those kind of things you will learn. Someone will learn through this process. When you start early, you have enough time to kind of get all this information. Although you are not even proactively doing it because you're spending second year, third year, fourth year doing all these things. At some point of time, anyway, you'll learn it. Even you are not putting some effort, you will learn it. The same thing, here, right? So it's a very very important thing to just do hard work and smart work both. Only smart work is also not enough because sometimes you have to put a lot of time for this, right? You have to be dedicated enough to do this. Now, along with that, I want to just one brief comparison of this kind of questions comes to everyone's mind that I'm not from IIT. Will I get to a very top rank university or not? Right? How life is different from two students who is from one from IIT and one is from not from IIT. Will it affect to which university he or she will get in US? Right. So what I would say, I will try to compare these two, and the final answer, the verdict that I have is very positive. That is that to some way it doesn't matter, and I'm telling you how. So if you're in IIT, things are a little bit easier because of the brand value, right? But that means branding is giving you some edge in terms of that, and of course because you get a network and going abroad for for internship and co-op relatively become easier because when you write an email to someone outside, when they see IIT, they have a little bit more trust. Okay, this is guys from IIT. Right? Now, what from someone who's not from IIT? In that case, because that brand effect may not be there, so you have to put some more hard work and extra work. That is definitely have to put. Someone has to put because you have to cover it up, right? And how can you cover it up when you're applying? For example, in the third year, you're applying for somewhere and you're writing to an email to an US prof. What he or she will see? Yes, you will check maybe you are from IIT or which university. So, but even if you're not from IIT, if you have a solid, research experience, you have done some projects, in your university, and in your supervisor in your university wrote a very strong recommendation, that professor will not mind because he knows that it's not always about IIT brand, because there are some exceptions also. People who are from IIT, they are not just lazy and not doing good work, and professor is pissed. Uh, right, that could be also scenarios are there. They know the exceptions. So that is the first thing. And from my personal experience, I want to say about two of the after my joining as a faculty here, I will not take the names, but there was one student. She approached me when she was in the fourth year for some project. So I said, fine, you can do it, great. And she is not from IIT, but she approached me. So, and she applied for many of the US universities in the first time. So, but her luck was not good that she didn't get anywhere, like almost nowhere. Then she was very kind of sad, what to do next. Then, but she was so motivated. She said, no, what I will do, I will wait for a year. I want to continue with you in the project. And that person also came to IIT and stayed because when someone comes from outside for she said, I want to do work for 6 months with you, but you cannot accommodate someone like that in an IIT campus. So she rented a house outside the campus, and, come to my lab and do it every year. And then she got a conference paper also, and she applied for a lot of universities. And I think out of all the university applied, very good university, she got acceptance. Now she's doing masters in University of Pennsylvania. So then one more example is there where that guy also worked with me for a long time after his fourth year, and I think he's in Colombia now doing masters. So there are a lot of people, students are there who are basically, what I see the difference is that they're so passionate and dedicated about the hard work. I mean, and they're so interested in the topic and they are ready to do hard work. And many times that is also sometimes what happens when you're in the IT system, that hardworking capacity sometimes you go down, right? Because I have the brand and thing is fine, I'll anyway get anywhere. But that becomes sometimes overconfidence also, right? So this management is required. But I think I have so many examples that which are not IT students from non-IT is doing very good in masters and PhD students in very top ranked US universities. So that is, I think, a good thing, right? To understand that, it's ultimately it ends up brand, hard work, smart work. If you don't have all at the same time, two may cover the third one, you know. So that's how I would say. But first of all, if you want to go for someone who goes to want to go for research, first of all, it has to come from inside. No one can pamper you and motivate you from externally, because at some point of time that person cannot keep you motivating, right? And at that time, when things go low, when you see that your classmate got a 50 lakhs package, and then you are not applying for jobs, in that point also you have to be so motivated that, no, I want to go for research, that's why I'm doing it. I have a goal in my life, no matter what is, I will reach there, I will put my 100%, 110% of my whatever I can. That kind of spirit has to be there, else someone should not go for research. That's how I feel.
I think that is very right. Research, because is in the long term, is a process that in which you'll face ups and downs, and when you
Yes.
face those lows,
Lows.
it would be very easy to be able to just regret your decision altogether.
Yes.
Because with a package and getting a job, you have that relative sense of security and a path
Yes.
carved out.
Right. Right.
Right, I have to keep on climbing the ladder, I have to
Mm.
keep on improving in so and so
Yes.
facet, I have to keep on working towards raising, getting a raise and all that stuff.
Yes.
With research, it's about you have to derive an output at the end of this 2 or 3 or 4 year
Right.
period.
Right.
How you get there, you have to carve that path out.
Yes.
And so I agree that calling has to come from within, with also a very rational and logical mindset and approach that you take towards
Exactly.
pursuing
Exactly.
that motivation and calling.
Right.
I would like to talk to you about generative AI.
Sure.
How does it work? A basic layout of its working and functioning. And secondly, its ethical considerations. What are its ethical implications, and what is the current all over demographic of the legal aspects of artificial intelligence in India, particularly,
Right.
like AI law and legal system, all of that.
Right. So when you talk about generative AI, you can think of like, uh, let's do a comparison with a simple task like classification, right? So in classification, what we do, we have some input and we decide in some feature space that which space it lies. For example, there are two classes. So in the some feature space, we can draw a line, and I say in the right side, if that particular input projects to that particular part of the feature space, it is a dog. It's in the left side, it's a cat, right? So I have this decision boundary and that decides thing. Now when you this is I am already having a dog image and I'm deciding what is a dog or cat. Now in generative AI, what happens is that I want to generate some a new sample, right? So for that, what I have to do, I have to figure out a way that can I get a dog sample from a dog distribution, can I get a cat sample from a cat distribution. So when I classifying something, I'm basically saying that this is a all possible dog images, right? Some distribution, and that particular image of dog is one of the samples from the distribution, right? Another picture comes of dog, there is another point of that distribution. Now if I have 100 pictures, I have basically 100 points in the distribution, some 100 samples, right? But I want to figure out that distribution itself to some way, so that if I now sample a new sample, I will be able to generate a new dog image which doesn't exist, but it is satisfying all these features of dog, right? So there is a kind of other way going, right? So when we do classification, we're sampling from the distribution, but when we're generating, we are sampling from the distribution without having that image. We want to go back to the image, right? So that's why this is a very difficult problem, because getting an explicit distribution of dog images or cat images is actually not attractive. I mean, you cannot track it in that way, right? It's very difficult to do. uh, so people have figured out with different ways to not to explicitly model it, the distribution, but some kind of hacky way, you can still generate something from it. So one very good example is GAN, Generative Adversarial Network, where what you do, you actually bring in a very interesting framework known as adversarial network, where you have a two models kind of competing each other, right? So you bringing in that adversarial techniques, we are avoiding explicitly creating that distribution, but somehow in a hacky way we are trying to figure out that if two models are competing, at the some point both are getting better because both are trying to fool each other, right? And in this process, this one model which is generating things, it just get better and better and better. Most probably you will be able to approximate the distribution in some way, right? So this is one kind of model where GANs are very popular for generating images. Similarly, these days we have large language models, right? So large language models, we have this concept known as autoregressive models. So for example, you want to um, translate a sentence from French to English, right? So you have this. If you look at this traditional transformer architecture, we have a you have an encoder and you have a decoder. So encoder takes the French sentence, and it maps that sentence to some space. Okay, let's say there's some spaces there. I'll come back to what the space is. Now decoder takes an English sentence, okay, but that English sentence doesn't exist because I want to translate that French sentence. So what I do, I start with a starting token. I give decoder a starting token, and then token is again transform to that feature space that I have talked about. So in that feature space, now this token and the French tokens, they can talk, because that is a common feature space where it doesn't matter what language it is, English, French, Chinese, they all can map to that space and they know each other what is the context, right? So we're lifting everything to that space. Now in when the starting token goes to that space and he looks at the French sentence in that space, it knows what to do next, because now they started talking, because in that space everything is same. Yeah, they are in the same context, and from there it figures out what is the next and predicts the first token decode. And now with the starting token and the first predicted token, they come together again, they predict the next token by going to that space and looking at the French sentence. So this way, step by step, they inference one by one by one by one by one. So this way they are generating by looking at the some common feature space, right? So this is a very interesting, because this gives this generative power, right? For example, you may not only translate, you may ask something to write an essay, right? So you, let's say, start with the one sentence or the prompt that you say, write an essay about this. So it goes to the decoder, and then decoder figures out that after that what should I predict. And because it is being trained with trillions of or billions or trillions of tokens, it has seen all the space what to do, and from that it figures out a pattern and figures out, okay, if this is a sentence, most probably this is the one way to go. It predicts the next word, it predicts the next word, and so on. So it continues to keep doing it, and during this process basically it generates a whole piece of prose, right? And behind the scene, of course, you have this transformer model, which is again based on attention mechanism. And one interesting thing that might connect to the one of the first questions that you asked, that I was wanted to mention, is that now these transformer models are kind of becoming so versatile, that they can take image also, speech also, text also, and they are laying the foundation of this multimodal AI, right? Because for example, if you take an image, say first let's take a sentence. What is this? This is kind of a bunch of words, right? And each word, more or less, you can sometimes is divided to two or so, but these are like tokens, right? Some kind of combination of tokens, bunch of tokens in a sequential form. These tokens can go into a transformer model and do something, right? Like predicting the next word or something like that. Now the scientists, what they have done, if you take an image, they can also think of it like a token. How? They are dividing into certain patches, and each patch is like a word, right? Because picture, you can also think of like a collection of words, right? Like each part of the image has some information and is like a sentence. If you flatten it, it becomes like a sentence, right? So they are considering that and putting it in the there's a special transformer known as vision transformer. So, and then vision transformer is again going through several layers of attention, and finally going to feature space where things are more contextual. And in that contextual feature space, they take can good decisions. And that's what actually happens, right? At the end, there's some embedding, and that embedding is nothing but a feature vector in that contextual space. They have transformed the original to recall, because the sentence, for example, when you say this is meaningful to humans, right, it's not necessarily the most optimized way of representing that thing for a computer. Now computer figures out by looking at bunch of examples that there's another way of representing that same sentence in a more compact way, or maybe more optimized way, or more conceptual way, and that space that it figures out by through the training process, right? So this way, these days, mostly when you talk about generative AI, we're talking about, for example, GPT, right? There's one of generative pre-trained transformers. So starting from GAN to GPT, GAN is also used in many cases. There are some models known as diffusion models. They can also become generative. There are naive Bayes, although it can be a classifier, it can also thought of as a generative models. So it has been, generative model is something not new. It's been done for a long time, but these days their capacity of building. Now, if you look at this new model came from Google also, right? That getting videos, View or something, right? And then we have Sora for from OpenAI. So those are now they're creating videos, very realistic looking ones. So it has gone a way forward, right? Now, with the advent of this generative AI, challenges are there. Uh, One example I recall, I did a long time ago in around 2018 or 19, I did this Kaggle competition on deepfake. So, and that data, that Facebook's competition, what $1 million prize, they generated some fake videos. They replaced mostly the face using GAN, right? So, and then the problem statement was that how can you detect whether that particular video is fake or real, right? So now generative AI is getting even far better now. I recall inside there were some images where in the early days, maybe in 2016, 17, you can still say that, okay, the face looks very real, but the background maybe looks a bit, fake. From that, you can recognize. But now, even that is not true. I mean, they can create everything so realistic, right? So, generative AIs are getting better. That's why ChatGPT is a generative AI that can create such a nice, output. Yeah, education, it's a becoming big problem, right? Headache. When they ask for an essay, they create with ChatGPT. Now that's why AIs are coming in to detect whether it's generated by AI or not, right? And now people are getting so smart that they are will create something that will detect, if an AI can detect it was detected by AI, right? It's becoming meta and meta. So it'll never stop. So because people will figure out that I have a plagiarism tool that can detect, let's say, it is written by AI or not. Now people are bypassing it by another tool, maybe Quillbot, rephrasing it so that the detector cannot detect. Right. So is kind of becoming a never-ending game. So ultimately, the future is AI. Uh, we have to figure out better ways to assess people. Right, like the old days of write an essay this way will not work. Right, unless it's on pen and paper, and you are in a classroom and you are being monitored without access of any smartphone or internet. That's a different thing, but that's what's happening. So, what to do with that? So right now I cannot exactly recall the name of the regulations or all these things, but what I can say is that this is not something now confined to researchers anymore. AI was like that before, right? Mostly, yes, some companies have started using AI tools. I mean, machine learning is also AI, and if you look at back in Google, they're using the spam and non-spam filters. They are based on naive base, and all these algorithms is also ML based, right? But now this is in everyone's hand. It was not like that before, right? Now anyone can download an app and create a fake image and things. So that's a very problematic, and that's why this is being discussed in in a government level, right? In the policymakers, they are also now considering these facts that AI is very important. If you look at US, Europe, they are very now bringing in stricter and stricter rules, regulations. Like, for example, it's not only about model, it's about data also, right? Data privacy and so on. For example, I recall uh, during my startup time, it was very difficult. I found it very difficult to start a data AI company in Europe. The reason is that they have this regulation known as GDPR, where the data is they care so much about data protection. This thing, you have to go through a certain approvals and this and that. And now some of the startups are so pissed about all these things, they are just moving to some other countries because they want to bypass all these things, right? Because it's making them slow. Because when you're talking about an AI company, it has to run very fast, go very fast. You cannot really wait for something data to come, getting approved, and so on. And we also know that Google and all companies getting so many high hefty fines, right? Because they did something that related to data. And so Europe, I think, is very strict in this. The regulations are being come in. US also, you might have heard recently, a lot of discussion have been going on in the sessions, in the senates and all. They always discuss about these things. Stricter rules, I mean, in India also, a lot of steps are being taken these days. I think they will bring in some regulations on this also. So it has been there and it has to be there, right? Otherwise it will go out of hand, uh, you will this is AI is such a superpower. And you think in last 2 3 years, the capacity of generative AI, even I being worked in computer vision for so many years now, like 6 years back, I cannot say that, cannot think of like the capacity of AI these days we have, right? It's unthinkable, to be honest. Like as a researcher, I can say it's unthinkable that such a nice way now they can generate things, right? The quality of the images they generate, the fake images, it's unbelievable, right? And you see this AI thing is always, these kind of technologies grow exponentially. Now you look at the slope of this curve in last 2 3 years, and now if I believe that it's going exponentially in next 5 6 years, how far it will go is right. So accordingly, regulations and all also has to be there, right? Because AI will slowly creep into the governance, or maybe some legal system. I don't know, right? And there will be some biases. If there is some biases in the data, how badly it will affect. There are a lot of incidents we see in US and Europe, where people are being wrongly, accused, because they started with some tools, AI tools, and later on they realized that it was biased to certain races of people, or some other kind of biases were there. Now who will check those, right? Because the scientists who are making those AI tools, they even don't know how this AI work in many of the parts. Now this is out of our hand, right? So I even cannot tell like how things will change in next 2 3 years regarding all this. But the good thing is that people are thinking about it. It's not that people are talking about AI ethics, people are talking about biases, right? And people are also talking about sustainability of the AI, because amount of compute it is being taken, how it is affecting our environment. Those things also has to be discussed, right? Now recently this model came, right, O3, by OpenAI. If you look at the amount of power compute it consumes for one task, it was saying some, 6 whole petrol pump or something. I don't know. Let's just some large number of compute is required compared to other models. So who will be responsible for that, right? If So we have to look at all these different aspects, and that has to be discussed. And uh, as I say that these days, if you pick up any AI textbook and all, they also started they talk about this. So it's all our responsibility, in particular who are working in AI. They should, I think, a couple of points they should always notice, I mean, to keep thinking, is that of course they are trying to bring in the best AI models. At the same time, they have to look for whether is being used for good or not, some good purposes. Is should uh, AI is great, but we have some real world problems, right? In terms of poverty, in terms of many other things. Those are very important problems to, as a humankind, to grow. So how AI can also be used for them, and that is, I think, a very important aspect that sometimes we often not think of.
I think that the greatest challenge right now is to make sure how the this invariable and inevitable exponential nature of the growth of
Right.
this technology at large can be kept up and kept under check with the advent and formulation of regulations and frameworks to be able to monitor it.
Right, right. That's very
Because
important. Yeah.
yeah, because the greatest slip up that we can do is not being able to keep up with the pace that this technology is
Yes.
growing
Yes.
and letting it go haywire.
Yes. I'm also afraid of that.
Yeah, but yes, I think that is also true that discussions upon these matters, as you said,
Yes.
are being held at
Yes. Yes.
various levels, at
Yes.
various platforms and forums,
Right.
which obviously discussions are good
Yeah.
if they are constructive and
Yeah.
they have a specific objective. I think it will lead to somewhere someday,
Right.
and sooner hopefully than later.
Right. Right.
But okay, moving on to the final segment of this conversation, Dr. Neog, what is your word to humanity at large?
Ah, so simple but very difficult question. But okay, let me think. So what I feel is that when I talk to people who are not in, in the area of research or designing those models, for example. So one concern they have is that, will AI destroy the world? Will it kill the humanity? Those kind of questions are there. And now we have to understand that only a very small proportion of the people in the world are doing research or actively know about AI. Right. So people have a lot of misconception about it. Right. So one thing I want to say is that, first of all, AI is not necessarily bad as they think. And I'm just borrowing one of your words. AI is inevitable in a way. It will come like any other revolutions that had happened in the past, right? And the greatest challenge for humanity right now is that how to adapt to AI at the same time, as you said, keep a check on it, right? So AI has definitely helping us a lot, making our life so convenient. There's no doubt about it. But making the people aware of what AI is one of the most important tasks right now I have. So what I mean is that education of AI. So that is very important. If we don't properly educate people with about AI, then they will have a lot of misconceptions and they may fight against AI, which is also not good. If we train a manpower which is aware of AI, then only we can create a better future which is driven by AI. So personally also I really encourage that AI education should be accessible to everyone, starting from even high school, 11 12 when they are there. And of course, one and the stream that they are from, whether it's science, commerce, arts, should not be a barrier to the learning of AI education. So we all have to work together on this, and AI should be accessible to everyone. Yeah.
Dr. Debanga Raj Neog, thank you so very much for being on the show. I'm really grateful and glad to have had this entire discussion with you upon specifically upon artificial intelligence at large, because all my previous discussions have been mostly related to the quantum realm and technologies, but I was really excited for this particular one because I knew that this would be entirely and thoroughly upon the matter of artificial intelligence. And thank you so very much.
Thank you. Thank you. It was really, really great to have a conversation with you. And I think you also asked some very, very relevant questions. And I tried my best to answer them from my own experience and expertise. It's great to be here.
I'm sure that people who will be watching this will be able to take some sort of a takeaway of any kind that would be constructive in nature.
Right.
So, yes, thank you.
Thank you.